All right, so your homework here is 490, 491, 92, and 493, and 494. I'm actually going to do 494 first because it's so easy and it looks so hard, and it's not at all. So we have m to the 5th power equals 50. And so our thought process should be, what number did we use 5 times to get 50? So 50 times 10, of course, and 50 times 5, 50 is 5 times 10, and 5 is, and then 5 times, and so there is not a whole number that I use 5 times to get 50. So in that sense, I guess it's slightly hard. It doesn't have an answer that makes any sense, which actually means I get to do less work. So to make this have an exponent of 1, I'm going to multiply it to the 1/5 power, both sides. So I have m equals 50 to the 1/5 power, which I could type into a calculator, not 1/2 power. 1/5 power, make sure that's a 50 and not an S. Or I could say the 5th root of 50. And again, the only way to answer this is with a calculator, but I can leave it like this, and this is a perfectly fine answer. And it's, I don't know if I can do a 50th root on the calculator on this computer. Let's double check. Nope. But I know how to find one. So Decimal Scientific Calculator, 50 raised to the 1/5 power. And so there's my answer. And 2.1867, etc. That's it. I could also use, if I didn't want to use a 1/5 power, I could do the 50. Let's put 50 inside. As I said, the 5th root, and you see that's exactly the same, 2.1867. And so it's really just up to me which way I want to go with that. 2.167, was it 87? It was 87. And that's it. Pretty straightforward. So again, this is one I've been dying to just do because it's so simple. Let's go back up to number 40, 940. So if we read the directions carefully, we can see that it's asking for the average rate of change. And if you were to Google average rate of change, you'd find a formula that looks a little complicated, where it says f of b minus f of a over b minus a. You might actually run into some calculus as you were looking this up. It might freak you out. But this is simply slope. Average rate of change is the same exact formula as y2 minus y1 over x2 minus x1. Basically, it's one ordered pair and another ordered pair, and we subtract. So it's really, really, really straightforward. It just looks overly complicated. It's not. So basically what we're going to do is see what it says. So average rate of change in salary per year for each offer during the first 2 years. So an annual increase in the first 2 years. So how much do we start? We start with this much money, and we get that twice. So first 2 years, and you would, of course, if you knew, you'd be using your previous answer, and you'd have an equation that you wrote during your previous answer. We're going to assume you did write an equation. Y equals 52,000 plus 3,000 per year. That's that one. And basically what we're going to do is plug in 0 and then 2. So we plug in 0. Let's plug in 2 first. 2 and 0 are going to be my numbers. That's what I'm plugging in. And if I plug in 2, I get 6,000 plus 52,000, which is 58,000. When I plug in 0, I'm going to get 52,000. And that gives me 6,000 over 2 equals 3,000. So that's the average rate of change for the first 2 years. The first 10 years, the only thing that will change for 10 years is I will be plugging in 10 instead. And so when plugging in 10, I'm going to use that calculator I found a minute ago. Clear. And so 52,000 minus plus 3,000 times 10. And so that's 82,000 minus 52,000 over 10 minus 0, which will give me 30,000 over 10, which is 3,000, which is to be expected because that was a linear equation. So that's my average rate of change. For my other equation, it's a little bit more complicated because my equation was a much more complicated problem. So my equation for this one is y equals 3,600 times 1.11 raised to the x. And so, same idea where I'm going to plug in my two numbers. So when I plug in 2, um, $3,600 parentheses 1.11 raised to the second power is that much money. I didn't actually process the number. It's gone. 443,556.6 minus the starting 3,600. That's what we'll get if we plug in 0 over 2 minus 0, which again we'll let the calculator do this for us, minus 36,000 is 8,355.6 minus divided by 2. Divided by 2, which is 4177.8. So that's the average rate of change, and we'll do the exact same thing. I'm going to leave you to do the 10 by yourself. You're going to do the exact same thing where you plug in 10, get the same answer. And so for your 10 equation, put the average rate of change function up here. You're going to go ahead and plug in 36, 1.11 to the 10th power minus 3,600 all over 10 minus 0. And so then your computer, and what you'll see is that the rate of change on this one was for 3,000 both times. On the second one, it's going to change. So that's that. Graph each system of inequalities. Use Desmos to do both of these. Go ahead and type in to Desmos for both of those. That would be my absolute suggestion. And then try to copy the graphs on here. You can also turn things really simply into a table of values on Desmos. I don't know if you've ever tried that. So like if I have an equation y equals 2x plus 3, I can turn it into a table of values, and that way I can plot the points more nicely. So I would highly recommend that you do that for these problems that I just suggested that you use Desmos for. That way it'll be much nicer to do. And so that's that. And then this one is trickier. I'm going to go ahead and help you with 92. So on this one, I'm going to go ahead and start by graphing my equation. I've got 8, a slope of negative 5 over 3. And there's my line. And I want to know the distance from this point, negative 5, negative 12, which is off the paper, to that line. And so that's a little tricky, but it is perpendicular. And one of the things I can do, if I move positive 3/5 towards the line, so I was at 12, so that'll be at negative 9/5. That's the distance to the line right there, so I'm really looking for that. That's complicated. What do we want to do? The other thing we can do is treat it like it's changing, because the shortest distance between two things is perpendicular. You think about that one. I'll give you an answer tomorrow, but struggle. Actually, we can see what CPM says, so I'm going to pause and take a look and see what some of their hints are. Alright, so I looked up the homework help for question 92, and it's basically what I thought I should do. Just wasn't sure, so you'll notice that I already did perpendicular slopes, right? The equation of the perpendicular line, I didn't quite do that, but I kind of drew it. It was 3/5 times the point x plus 5 minus 12, and where they intersect, which is 7.5, comma negative 4.5. So now that I know that point, I'm going to go ahead and use it. 7.5, comma negative 4.5, and then I can do the distance. And so distance formula D equals the square root of a mass, and my mass is very specially the distance between these x coordinates, between negative 7 and between negative 5 and 7.5 is 12.5. We're going to square that, plus the distance between negative 12 and negative 4. Between negative 12 and negative 4 is 8, so it's 7.5 because I didn't quite make it all the way to 4. And I'm also going to square that and then let my calculator crank that one out. We'll let our calculator crank that out for us. And it was the square root of 12.5 squared plus 7.5 squared. Make sure I have the right numbers. Yep, that's that. And so the answer that was on the calculator a minute ago, you can back it up and see what it is. The answer, almost out of time here. Write equations so they intersect exactly 1 point, no points, or 2 points. So if you want to stick with lines, you could then you could get no points by doing parallel lines. 1 point, you could also stick with lines, making sure they intersect. 2 points, you'd need a quadratic and a line because there's no way to get that with anything else. So that's your idea. To kind of be creative because you have lots of choices. I would go with 2 lines here. And then I would also use 2 lines here. And then this one I'd use a parabola and a line. And just come up with some fun equations. I will see you guys soon. Bye.